Okay, let's get going on. If we're given a graph of a parabola, working towards finding the function that would create that graph. So we do have two different versions of our quadratic functions. We have the general form, where it's expanded out, and we have the standard form, where it's written like this with h and k. Sometimes this is referred to as the vertex form. All right, we don't really need to worry about these formulas to locate the vertex because we have a graph given to us on this one. So as we get going, we're given a graph. We want to get this eventually to general form. So in moving the right direction, we want to locate 2 points on this graph. One point always want to be our vertex. So our vertex in this case looks like it's up at the top here, so -2, comma 4. So locate the vertex and then locate one other point that you're really confident is actually going to be on our graph. On this one, it seems to be indicated that either -1, 1 or -1 or -3, 1 are going to be on here. I'm going to use -3, 1, the point on the left-hand side. This would also work if you pick -1, +1. All right, so after we have our 2 points, let's go and use our vertex to move around our graph. So that really corresponds with hk. Well, what we can write is f of x, our function name. You could call it g of x or something else. We'll leave a out here. A is going to be some sort of scalar multiple, either a stretch or a compression, maybe a reflection. I'm thinking this will have a reflection because it's facing downwards. Then on the inside here, we have our x, and then we're going to shift this to the left 2 units. So I'm going to put a 2 in here attached directly to x. And it is added to x because that kind of works counterintuitively. That adding 2 directly to x, like grouped with the x, is going to move everything to the left 2 units. And remember, our standard x squared graph has the vertex at the origin at 0, 0. The next thing that we're going to do is we've moved everything up for the vertex 4 units, so we're going to attach a +4 at the end to everything. Now, up and down transformations work exactly how we think they should as far as their sign goes. Adding 4 is going to move everything up 4. If you had subtracted 4, that would move everything down 4. All right, so we've used our vertex, but the next thing we want to do is we want to use that other point that we found. All right, that's an x value for -3 and a y value for 1. So y, or f of x, is going to get 1 equals a times, I'm just filling in here, -3 + 2, quantity squared, +4. Now we have an equation that only has one unknown. We don't know what a is, so our next goal is going to be solve down for a. So I'm going to go ahead and subtract the 4 to the other side. So we have -3 equals a times, a little bit of simplifying here inside the parentheses, -3 + 2 makes -1. And as we square it, that's going to be a multiplied by 1 on the right-hand side, or just a. All right, therefore, our function, now that we found a, we can plug that back into the function we created, put a -3 in for a, x + 2 quantity squared, +4. And that almost gets us to where we want to be, except for that we were asked for general form. The general form, as you'll see up above, is the expanded out version of the same formula. So to get there, what I'm going to do is just go off to the side here. F of x is going to be, I'm bringing my -3 along. All we need to do is expand this out, so multiply it out. So that exponent of 2, I'm going to treat that as 2 copies of the base multiplied together. I'm going to bring my -3 along, and I'm going to do first, outer, inner, last. I'm going to distribute those 2 binomials. So we get x squared plus 2x plus 2x plus 4. And a little bit more expanding, I'm going to distribute the -3. We could combine those like terms together first. I'm going to take just a second before I do that, but -3x squared minus 6x minus 6x minus 12 plus 4. Combine our like terms, and we are home free. -3x squared minus 12x minus 8. And now we're in the expanded form, or the general form, for our polynomial. Our second degree polynomial, which we refer to as a quadratic. All right, let's do one more of these real quickly, following the same procedure. What we're going to do on this one is, again, locate that vertex, the lowest point. In this case, I think it's at 3, 1. and then locate one other point that we know we're really, really sure is going to be on our graph. Zoom in on the graph as much as you need to, blow it up. If you're working on online homework, I would go with maybe this y-intercept is going to be at 0, 7. So now we know 2 points. What we can do is off to the side set up f of x is going to equal a, and then we have x, and we've shifted this to the right 3. So we put a 3 in there with the x. Since we've moved to the right, it's going to be a subtraction here. So that's going to create that right 3 movement. And then we moved everything up 1, so we're going to put a +1 at the end to indicate that transformation. All right, next up, remember what we do is we take that other ordered pair that we found, that's an x value and an f of x value, and I'm going to plug in 7 for f of x, a times 0 minus 3 quantity squared plus 1. Now we have an equation with only that one unknown, the a, so let's go ahead and solve for a. So subtract 1 from both sides, we get 6 equals a times -3 squared. So that's going to be 6 equals a times 9. Divide both sides by 9. We'll get a all by itself. It turns out being positive 2/3. Now we should expect that to be positive because our parabola is facing upwards. And our last task here is to get it into general form. So right now, if we plug that back in, we can say f of x is going to be 2/3 multiplied by the quantity x minus 3 squared plus 1. To get it into that general form or expanded form, I'm going to do a similar process where we bring the 2/3 along, visualize this as 2 copies of x minus 3 being multiplied together. Next, I'm going to go ahead and expand first, outer, inner, last, or distributive property. So x squared minus 3x plus 9. Bring that plus 1 along from outside. Do a little bit of distributing for our 2/3. So I have 2/3 multiplied by x squared minus, as we multiply 2/3 times 3, the 3's get to cancel out. So we just get 2x, and the same thing for the next term, another 2x, and then 2/3 times 9 is going to work out to be 6. Finally, combine our like terms, complete this general form. 2/3 x squared minus 4x plus 7 will be the general form for this parabola that was graphed for us. All right, hope this helps out. A couple examples to get you moving in the right direction from starting with a graph of a quadratic and getting the function in general form that goes with it.